Okay, so free response number 5, two different questions. We could do 2 parts on this one. So this would be no calculator allowed, so no decimals. And it's a cylindrical water problem. So it looks like we've got 2 feet for a diameter, which means my radius is 1 foot. And they give us dHdt. And they were kind of nice. They gave us the volume formula. So what they want on part A is find the rate of change of the volume of water. So we want, I'm going to write it here, dV dt, when the height of the water is 4. So when h equals 4. Okay, and indicate units of measure. So since it's a change in volume, that will be feet cubed per second. All right, so, well, we know that volume equals pi r squared h. And as the water goes down, what we know is that the radius of the water is never going to change. So we can substitute that right now before we do our derivative. So if r is 1, we would get pi times h. All right, and we want dv. So I'm going to take the derivative of both sides with respect to time. This would be pi, and then the derivative of h is dh dt. Well, they give us that. So dv dt equals pi times this. Right. And I always like to write it before I actually plug in the values. Just, you never know what they're going to give you points for. So now I can substitute h equals 4. So dv dt equals pi. And so what's that? 2. So I get dv dt equals negative 1/5 pi feet cubed per second. Okay, so let's look at our point values. So the way the points are distributed is we get 1 point if you have that on your paper written out, and you get 1 point for your answer with units. If you don't have the units, you don't get the point. Okay. All right, so part B says when the height of the water is 3, is the rate of change of the height increasing or decreasing? So dH increasing or decreasing. So if something's increasing or decreasing, it refers to the derivative of what you want. So what I want is the derivative of dH. So what I really want is the second derivative. Okay. If my second derivative is positive, it's increasing. If my second derivative is negative, it would be decreasing. So we know that dH dt is equal to negative. This was given. I'm just going to write it, and I'm going to change this. Okay. So the derivative of the left, and this, well, I'm going to bring that power down. So negative 1/20 h to the negative 1/2 times dH dt. Okay, still implicit derivatives. So we get our second derivative. It's negative 1/20 times, let's see, I'm going to put the h down here. And then dH dt, once again, is negative 1/10 root h. Okay, so if we clean this up, we actually get d squared h over dt squared is, well, even if I didn't clean this up, I know a negative times a negative is a positive 1/200. So what we can say is that since d squared h over dt squared is greater than 0, and it really is for h is greater than 0. You won't get that marked off if you don't put it though. But the rate of change of height is increasing when h equals 3. And I didn't really even need to plug in my 3. It wouldn't have mattered. But you want a statement that talks about the second derivative being positive and what is increasing. Okay, so make sure that's clear. All right, so our points. Let's see what we get. We get 1 point if we have this. We get 1 point for just this. Okay. And then we get our 3rd point for all of this. Okay. All right, so that's the 3 points. Let's go to the next question, which is about motion. So this one, once again, would be no calculators allowed. So we've got a domain restriction from 0 to 8. The position, so this is my original function, is a natural log, and this is velocity. So this is my derivative, velocity. And they tell us this. Now, this information might not get used on this part, but there are other parts that eventually we will be using that for. So from 0 to 8 for time, when is the particle moving to the left? So it's moving to the left when the derivative is less than 0. So when the derivative is negative. Or velocity is negative. You can think of it that way because that's the derivative. So here's our velocity. And we're going to set it equal to 0 so we can solve. Oh, wait, hold on. Particle P, so never mind. That's particle Q. I need to pay attention. So that's Q. And this is for P. All right, so let's start over. So I know that X P of T is this. Almost made an error. Our derivative is 1 over the inside times the derivative of the inside. Okay. I'm just going to factor this. 5 and 2. This doesn't factor, so we'll leave that alone. All right, so what I want to know is when my derivative is actually going to equal 0. So I know when it might change directions. Okay, so if I look at the denominator, it doesn't factor. And no matter what numbers I plug in, it's going to be positive for all. So I can multiply by the denominator. So I really get 2t minus 1 equals 0. Divide by 2. And add 1. Okay, so now at 1, it could possibly change directions. So I'm going to make a little number line. So this is V of P, velocity. So I'm starting at 0, I'm ending at 8, and I know at 1. So I'm going to plug in a number into my derivative and to find out if it's positive or negative. So if I plug in 1/2, so I would get, you just want an estimate. I get a negative times a positive, so I get negative on top. And then 1/2 squared minus 2 times 1/2 plus 10 is going to be positive. So negative divided by positive is a negative. So we know we're moving to the left. But that doesn't mean I don't move to the left there. So I'm going to try like 5. So 5 would be positive times positive. If I plug in 5, 25 plus 10 is 35 minus 10 is positive. Okay, so that means I'm moving to the right. So what we know is particle P moving to the left from 0 to 1. I think interval notation is the easiest way to write it. They don't need to know why, but you always want to have some work because you might get points for that. Okay, so let's check the point values. We get 1 point for our derivative, even if it's not cleaned up, and we get 1 point just for the interval. Okay, you don't have to write this in interval notation. you could say from 0 to t is less than 1. Whether or not you include 0 actually is irrelevant. So, okay, part B. So for 0 to 8, find all the times t during which the two particles travel in the same direction. So what we know is my particle p, we know 0, 1, 8. We know it's moving to the left and then it's moving to the right. What I want to compare is, what was it, q? Yeah. So x q of t, how is it moving? Okay. So we know that particle q is that, and that's the velocity. So we've got we want to set this equal to 0 to find out when it is at rest or changes direction. So this is factoring. So t minus 3, t minus 5, set them equal to 0. Okay, so I know 3, and I'm going to line this up, and 5. Okay, and so now I need to test if it's positive or negative. So I'm just going to try 1, and I'm writing this for you. I also write it for the reader. So if we plug in 1, we would get a negative times a negative. So it's moving to the right. If I try 4, so 4 positive times a negative. And they don't always alternate, but they do a lot of the times. And then let's just try 6. 6 minus 3 is positive. 6 minus 5 is positive. So moving to the right. Okay, so now we need to do a little comparison. So what I notice is from 0 to 1, they're not moving the same direction. From, and I'll just put like a little 1 here. From 1 to 3, so 3 would be about right here. From 1 to 3, this one's moving to the right. And from 1 to 3, this one's moving to the right. So from the right, 1 to 3. Okay, so 3 to 5 is a chunk. So at 3, P is going to the right. And from 3 to 5, Q is going to the left. That's opposite. So then from 5 to 8. From 5 to 8, P is to the right. From 5 to 8, Q is to the right. So they just happen to both be going to the right. So both P and Q, right. Okay, so, and I would just say, they don't ask us why, so you don't have to worry about it. But because we'll just say the velocity of P and the velocity of Q have the same signs. All right, let's look at our point values. So this is where 2 points. So if you don't have any analysis shown, you actually get no points, okay? So if you just have answers and you don't show any work of comparing the two, you get nothing. If you only get 1 point if only one interval is shown. So you need both of these on this square, okay? So you get 1 point if you have the intervals, and then you have 1 point for your analysis, okay? Part C is also worth 2 points. So part C says define the acceleration of Q at time t equals 2. So what we want is A of 2 for Q. All right, so we know our velocity of Q is t squared minus 8t plus 15. So acceleration of Q is the derivative, so 2t minus 8. And we want when t equals 2, so A of Q of 2. Oops. 4 minus 8 is negative 4. Okay, so that's A of 2. So is the speed of the particle increasing, decreasing, or neither? So what we want to do is we want to compare velocity and acceleration. So I know the acceleration at 2 is negative, but what's the velocity? So velocity of 2 is 2 squared minus 8 times 2 plus 15. 4 minus 16 plus 15, so 19 minus 16, so I get 3. So remember, we want to compare. So because my acceleration is negative and my velocity is positive, they're working against each other. So we are going to say at t equals 2, the speed of particle Q is decreasing because V of Q and A of Q have opposite signs. You can use notation, but the words are great. All right, let's look at point values. This is where 2 points. You get 1 point if you have this labeled, and you get 1 point for the reason, because it says explain your reasoning, and the right answer. Okay, so you do have to do a comparison between velocity and acceleration, and you really can't say anything else except they have the opposite signs, or one is positive and one is negative. So you can write that out in words. Okay.